Okay, here are the review solutions. I have included some little bit of explanation for a couple of them, but for the most part I just put the answers. Send me an email if you have any particular questions. I don't know how early I will get to school tomorrow, but feel free anytime today to shoot me an email, send me a screenshot of the work, and say, hey, I'm stuck here, that's what I'm trying to do, I can't get it done. And I'll certainly help you out. Best of luck studying today. If you are, of course, in any need of help, let me know. And if you're watching football, enjoy that. First one is true. We've talked about that. We've talked about this one quite often. What you're looking for, you have this point 112 along with the curve 9 minus x squared. And so what you want to realize is that your tangent lines have to both have the slope of the curve at that point and have to have the slope that you would get if you connected a point on the curve to the point 1, 12. So you find both of those slopes. One is the instantaneous rate of change, and the other is just the slope between 2 points. Any point on the curve is given by a comma f of a, and this point is 1, 12. So you can just subtract y values, divide by the subtraction of the x values to get that slope. And then that allows you to find the 2 points at which those slopes will match up, and then you can write the tangent lines at those points given the slope that you've already found. Number 3 requires you to kind of look back at number 21. You want to find the instantaneous rate of change for any value a, and so you take the limit as f of a plus h minus f of a over h as h approaches 0, and you get 1 over a minus 1 squared, and so that's going to be your slope at any point a, and we want to know when that is equal to 1, so you set it equal to 1 and solve, and you can write your values. 95, number 47 and 48, these are kind of just for you to experiment. So if you did them, great. You can look at the answer of number 47, and if you want to come in, we can talk about 48, but I wouldn't necessarily prioritize it right now for the test. Find the tangent and the normal of the curve at y equals the absolute value of x when x equals 0. And so here what you have to realize is the absolute value of x is a function that looks like this. And so when you find the slope coming from the left side and from the right side, you get different values, because coming from the left side, h is going to be a negative value, so that makes it negative, and coming from the right side of 0, h is going to be positive, so that gives you a positive 1. So since the limit that we use to calculate our slope doesn't exist, well, there's no way that we can write a function with a slope that doesn't exist, so there's no tangent and, of course, no normal. Okay, these are the solutions to these following problems, so go ahead and take a look. I think these are all pretty straightforward. Remember here that sine of 2x over x is 2. You can pull out the 1/4. Here the positive infinity is the limit as x approaches positive infinity, and the negative infinity is x approaches negative infinity, because this cubic will be negative when you have really big negative numbers. Here, remember that we want this to be continuous. So what that means is that the limit has to be equal to the value of the function at that point. Well, we know that the limit is the limit as we approach from the left and the right of this function. Well, that's going to be the same, right, because we're using the same function and this is a continuous function. However, at x equals 3, we're using the value k. And so whatever that limit is that we get has to be the value of k so that they meet up at the same point. We don't have to take our pencil off the paper. Again, here fairly straightforward. I don't think there's anything that should be overly confusing. Of course, if you do find something, please shoot me an email. These are pretty straightforward. One thing to notice is here we need to look at the limit to determine whether or not the tangent exists. In other words, we need the slope as we come from the left side of 3 pi over 4 and from the right side of 3 pi over 4. Those need to be equal, right, because they're meeting up there. And so if they're not, then they won't have the same slope. And they don't, so that since the limit doesn't exist, it's impossible, these are discontinuous, so it's impossible for us to have one slope right at 3 pi over 4. All right, these are the answers to the last three. These are a little challenging, but if you work through them, certainly you'll feel as though you should be prepared for any type of free response regarding limits and continuity and whatnot. One of the tricky things for part A of 57, you're finding all the zeros of f, meaning you're finding all the roots, which boils down to when is the numerator equal to 0, so long as the denominator isn't equal to 0. Well, the denominator is never going to be equal to 0, so you're just finding the roots of this third-degree polynomial. Honestly, you would probably want to use a calculator if you're allowed. You can graph it and find the roots, or you can use Wolfram Alpha, obviously not on the test. But what you can also see is that x equals 1 would work. And once you know x equals 1 works, you know that, I'll write it over here, that x minus 1 is a factor. And so you can now divide x cubed minus 2x squared plus 1 by x minus 1 and find the other two factors. And well, you'll actually find the quadratic, and then you can use the quadratic formula to find the roots of that quadratic, which are this, plus or minus. So you get 3 roots. So that's a little bit tricky. And then part B is just asking what is the asymptote, and it's not an asymptote that we're used to seeing. It's not a perfectly horizontal line, right? And the reason is that if we look at the limit as x approaches infinity, we actually will get infinity. And so what we have to realize is that that's because this numerator is getting bigger and bigger. And so we look at the leading terms, x cubed and x squared, and we realize, oh, these are the terms that are going to matter when we're getting really large values of x. What is x cubed over x squared, really? It's just x, right? X cubed divided by x squared. And so that's how we get the function for b. Okay?